Okay, let's take a look at your friction lab. I said I'd talk about the write-up. So the write-up starts exactly the same way as they all do. You do a cover page. You copy your purpose down word for word. Underneath the purpose, before the materials, you write in your hypothesis. And I gave you 3 of them to predict today. One was what would happen as you stacked more books on top of book A, what would happen to the coefficient of friction. The second was what will happen to the coefficient of friction when you pull it on the spine. And the third one was what will happen to the coefficient of friction after we pledge the table. Okay, so purpose, hypothesis, materials, exactly what's here. And then remember, you need to rewrite your procedure, past tense and impersonal. So using a spring scale and some string hooked through the pages of a textbook, find the weight of each textbook you were going to use. You would say something like, using a spring scale and some string hooked through the pages of a textbook, the weights of each textbook that were going to be used was found, period. These weights were recorded in a separate chart that was created. Take out the use. Second one, you were about to pull the first textbook across the table. Estimate the amount of force that you will need to apply to the scale to attach to the textbook. So you would say, before the first textbook was pulled across the table, it was the amount of force needed was estimated, okay, etc. All right, then in your results, 2 things in your 2 tables in your results. One with the weights, and then the second one is this one down here that you need to recreate with everything filled in. Now, filling this in. So we talked about it, I think, already today, but let's just make sure you got it. So the friction is the force you're pulling with, right? So here's my book on the table. I pull with a force this way. If I'm pulling at constant speed, then what the spring scale is reading should be equal to the force of friction. So that's why you wrote right? Because the sum of the forces in the x direction is equal to max. But if you were indeed pulling at constant speed, then F minus friction is equal to 0. So F should be equal to friction. So you should be reading the spring scale would be equal to the frictional force. The normal force is what tends to mess people up. So Fg going down, Fn going up. So when you do sum of the forces in the y direction, it'll be Fn minus Fg, just like it always is equal to 0. So Fn will equal Fg, which will equal mg. Okay, so for book A, the normal force is equal to the weight of book A. But in the next trial, you stack, or the next one, you stack B on top of it. So now what will be the weight? It should be A plus B together, right? So in that first chart, you need to add A, B, C, etc. Okay? All right, so then once you have your charts completed, those first couple of columns, leave them it's coming. Okay, so number 1, question 1 says, compare the book's weight with the force required to pull it horizontally at a constant speed. Which one is larger? And how accurate were you with your estimates? So just talk about what you found comparing these two and how you did with estimating. Number 2 says, it always takes more force to start an object than to keep it moving. Why? So it goes back to our conversation about static and kinetic friction. Okay, so this time I want you to explain it to me. Number 3, does it take more force to pull an object at a higher constant speed than a slower one? So today in the lab, I asked you to pull it at a different speed. It was step, I don't know, 5 maybe up here. Yeah, once more at a different constant speed. So what did you find out? Does the force of friction depend upon the speed of the motion? So I want you to answer that. Number 4, the force of friction was found in the procedure. Would it be more or less if you pulled the same books across ice, across sand, across rough concrete, across wax floors? So you just need to say more or less for each one of these. And then it says, how is the force of friction affected by changing the surface from smooth to rough? So you need to answer that, which should be okay. Number 5, write the equation showing the relationship between the force of friction and the normal force. That's our fun guy they want you to write, okay? So here are your calculations coming. And then it says, use the equation to calculate the coefficient for each of the things. So you're going to write out mu equals FFR. Oops, I think my pen's dying. Oh, you're not going to write that out. FFR over Fn, and then you're going to do it for book A, you're going to do it for book A plus B, okay? And then all the mu's you're going to fill in here. All right, so that's number 5. And again, as always, you can either leave a space in your lab and carefully write them in. You could do it on a separate sheet of paper neatly, or you could type it in, whatever you want. Number 6 says, what are the units for mu? Well, hopefully you know that. Number 7, it's in bold. Do you notice? It's in bold. Plot a full page graph. That doesn't mean a little graph in the up top or top corner, itsy bitsy. Full page, the whole page on graph paper, okay? With the force of friction versus the normal force. So which one goes where? The force of friction versus the normal force. You're going to put friction here and the normal force here, okay? You're going to do it on graph paper in full page. I'm just going to sketch it here. Okay, so you're going to figure out your scales. You're going to plot your points. So, and notice it says for the first 4 trials. So for A plus B plus C, and A, B, D, and C and D. So just the first 4, not the one on the spine and not the 2 on the pledge surface. Okay, so you're going to plot them. They might not all line up perfectly. They might look something like that. And then it says, draw the line of best fit. So a line of best fit doesn't mean you go dot to dot and hope for a bunny rabbit. Line of best fit is the line that's going to go through or as close to as many of these as possible. Now, this one, it really should go through your origin. I just didn't do a very good job when I was randomly putting dots here. So let me randomly put a few like this. Okay, line of best fit goes as close to as many of them as possible. If you had a point down here, you would ignore it, right? Just like if you, like this guy, I ignored because he seemed to be off the line. So you take a ruler, even though I didn't, but that's because I only have one hand. You take a ruler and you draw the line as close to as many of the points as you can, and then it says find the slope of the line. So when you're finding the slope of the line, you pick 2 points on the line. 2 points that the easiest would be that are on like the grid markings. Okay, so I might pick these 2 points. I certainly wouldn't pick these 2. Why? Because they're not on the line. So you'd be finding the slope of not the line. So pick 2 points that are on the line, and remember slope, pont, is y2 minus y1 over x2 minus x1. Okay, so it wants you to find the slope. Then it says, based on your graph, what is the relationship between the force of friction and the normal force? And then how do the coefficients of friction compare? Oh, I don't think I asked you, but I do want to know, what will this slope be? Okay, so tell me what this slope will be after you find it. And then the last one, how do the coefficients of friction compare for you for the 7 trials? Is it how they should be? So you look at all of these. Did you get what you were expecting? What should have happened? Okay. Then sources of error we'll talk about quickly at the beginning of our next class. And then, of course, your conclusion. Okay, so it's the graph I'm most worried about. You might want to try to do it before you come back the next day so that when you have issues, I can help you with it before it's due. All right, very good. Go and practice some force questions and work on this.